Good afternoon, mathematicians. I am Miss Erica B. Filomeno, 4th year BS Ed Mathematics student. And for today's video, we will be talking about the parabola opening to the right with vertex at the origin. So to find the parabola opening to the right with vertex at the origin, the focus is at point A and 0, where A is any positive number, and the directrix must be opposite to the focus. That will be x is equal to negative A. So, the latus rectum of the parabola opening to the right is from the definition is equal to 4A. So, we have to divide it by 2. So, we will move upward at 2 units, 1, 2 from the focus. And the other 2, we will also move a unit of 2 from the focus, 1, 2. So to find the parabola opening to the right with vertex at the origin, the formula that we will be using is the y squared equals 4ax. So let's say for example number 1, sketch and discuss y squared equals 4x. So to find that, the solution first is we have to determine the A. So the A from the equation that is given is 4. So 4A is equal to 4. And to simplify that, we have to divide 4A to 4, and that will be A is equal to 1. So from that, we can find the focus, and that will be point 1 and 0. And we can also get the directrix, and that is the opposite of the focus, and that is x equals negative 1. So the length of the latus rectum, or LR, is from the definition LR is equal to 4A. So we have to substitute A from this one. A is equal to 1. So LR is equal to 4 times 1. So the answer is 4. So the length of the latus rectum is 4. So because of that, we can find or we can draw the graph. So when we graph the equation y squared equals 4x, the focus is point 1 and 0. So it is here. And the directrix is negative 1. So it's here. And the length of latus rectum, which is 4, or when we divide it to 2, it is 2. So we will move upward a unit of 2. 1, 2. Downward, we will also move a unit of 2. 1, 2. So the parabola will look like this. So let's proceed to example number 2. Find the equation of the parabola having its focus at point 2, 0 and the directrix x equals negative 2. Find the LR or the latus rectum. So the solution is first we have to find the A. So from the given, focus is at point 2, 0 and the directrix is equal to negative 2 and the LR. So we have to find the LR or the latus rectum. So from the given, we can determine the A, and that is now equals to 2. So we can find now the latus rectum. The equation of the latus rectum is LR is equal to 4A. We have to substitute the A. LR is equal to 4 times 2. So the length of latus rectum is equal to 8. So since its part is already complete, we can now find the equation. So from the standard form, y squared is equal 4ax, where a is equal to 2. So we have to substitute y squared equals 4. The a is equal to 2x. So that will be y squared is equal to 8x. So the equation is y squared equals 8x. So to graph the equation y squared equals 8x, so the focus is at point 2, 0 here. And the directrix is opposite to the focus, and that is x equals negative 2 here. And the LR or the latus rectum is equals to 8. So we have to divide it to 2. So we move a 4 unit upward. So 1, 2, 3, 4 from the focus. And the other downward 4 unit from the focus. 1, 2, 3, 4. So the parabola will look like this. LR is equal to 8. So let's proceed to example number 3, our last example. Find the length of latus rectum and the equation of the parabola with vertex at the origin, and the axis of the parabola is along x-axis passing through the point 3 and 6. Draw the graph. So the solution is using the given point 3, 6, we have to substitute it from the standard form y squared equals 4ax. So 3, 6, this is the x and y. So from the standard form, y squared equals 4ax. The y here is 6. So we have to substitute it by y. So 6 squared equals 4a, and the x is 3. So that is 4a3. So 6 squared is equal to 36. 6 times 6 equals 36. And 4a3 is equals 12a. So to simplify it, we have to divide it to 12. So 36 divided by 12 is equal to 3. So the a here is 3. So since we already found the a, so we can complete the focus, the directrix, and the latus rectum. So the focus is 3, 0. And the directrix, it must be opposite to the focus. So the answer is x equals -3. And the latus rectum, or the length of latus rectum, from the equation LR equals 4a, we have to substitute a by 3. So this will become 4 times 3. So the answer is 12. So the latus rectum is 12. So since we complete the parts, we can find the equation. So the equation of the parabola, from the standard form, y squared equals 4ax, where a is equal to 3, y squared equals 4 times the a, 3x. So the answer is y squared equals 12x. So this is the equation of the parabola. To graph the equation y squared equals 12x, the focus is 0.30 here, 1, 2, 3. And the directrix is opposite to the focus, which is -3, -1, -2, -3. So it's in here. And the length of latus rectum is 12. Divide by 2. So we will move upward a unit of 6. 1, 2, 3, 4, 5, 6 from the focus. So it's here, point here. And another 6 downward, unit of 6. 1, 2, 3, 4, 5, 6. So it's here from the focus. So the parabola will look like this. So the latus rectum is equal to 12, and the directrix equals x -3. So that is the form of the graph of the equation y squared equals 12x. So that is how you will find the parabola opening to the right with vertex at the origin. I hope you understand and learn for today's topic. So again, good afternoon mathematicians. This is Miss Erica B. Filomeno from BS Ed Mathematics. Bye-bye!